At midnight, the lights go out. Every single one. No soul was left alive. New York plunges into darkness. London falls silent. Tokyo's neon signs die. 8 billion human hearts stop beating in the same terrible instant, and Earth spins on, indifferent, patient, eternal. What would remain of us? In 10 million years, would anyone even know we were here? This isn't science fiction. This is the question that keeps NASA scientists awake at night, because they've run the numbers, and the answer will shatter everything you thought you knew about human history. Lean back. Subscribe. What you're about to hear isn't just another story about the past. It's a dark truth hidden in stone, written in chemical signatures older than memory itself. A secret that changes everything. Subscribe now. Then let's dive in. The year is 2018. Deep inside NASA's Goddard Institute, two brilliant minds stare at computer screens filled with data that shouldn't exist. Adam Frank, an astrophysicist hunting for alien civilizations across the cosmos, sits across from Gavin Schmidt, a climate scientist who models Earth's ancient atmospheres. Between them lies a question so dangerous, so paradigm-shattering, that most scientists won't even whisper it in academic halls. What if we are not the first? They call it the Silurian hypothesis, named after those reptilian aliens from Doctor Who claimed Earth as their birthright millions of years before humans crawled from the primordial soup. But this isn't entertainment. This is hard science wrestling with an impossible possibility. Adam Frank's fingers hover over his keyboard. If an industrial civilization existed on Earth millions of years ago, how would we know? The cursor blinks, waiting, accusing. Schmidt pulls up geological data spanning 4.5 billion years, every ice age, every volcanic eruption, every moment since Earth first cooled from molten rock. His expertise tells him the planet keeps records, chemical fingerprints, isotope signatures. The question is, do we know how to read them? What they're about to discover will make your blood run cold. Imagine Earth's entire history compressed into a single year. January 1st, the planet forms from cosmic dust and fire. March, the first stirrings of life. November, the first complex animals. December 31st, dinosaurs rule the world. December 31st, 11:59:58 p.m. The first human settlements. Everything you know about civilization, the pyramids, the Roman Empire, the Renaissance, the Industrial Revolution, 2 world wars, the moon landing, the internet, all of it happens in the final 2 seconds before midnight. 2 seconds. We are a cosmic eye blink, a whisper in the geological storm. And if we can rise from nothing to split atoms and decode DNA in just 2 seconds of Earth's timeline, what could have happened in all those empty hours before us? The mathematics are terrifying in their simplicity. Earth has had 4.5 billion years to experiment with intelligence. Hundreds of millions of years have passed since complex life filled the oceans. Vast epochs where continents drifted, climates shifted, and evolution had endless opportunities to craft minds capable of building cities, smelting metals, burning forests for fuel.
Why do we assume we're the first to try? Ancient texts whisper of worlds before this world. Hindu scriptures speak of endless cycles, ages of gold dissolving into darkness, only to rise again like phoenixes from cosmic ash. The Yugas, vast wheels of time where civilizations bloom and die across millions of years. Plato wrote of Atlantis, a maritime empire that, in a single day and night of misfortune, disappeared into the depths of the sea. He claimed it wasn't myth, but history, passed down through Egyptian priests who guarded memories stretching back 9,000 years. 9,000 years, deeper than our oldest cities, older than agriculture itself. If Plato's priests could remember that far back, What happened in the millions of years before memory began? The Mesopotamians carved flood stories into clay tablets, describing how the gods grew tired of humanity's noise and decided to wash the world clean. Norse mythology tells of Ragnarok, the end of gods and men, followed by a new world rising from the flooded ruins of the old. Indigenous peoples across the Americas, isolated for thousands of years, tell nearly identical tales of global catastrophes that drowned entire civilizations. The Hopi speak of previous worlds destroyed by ice, by fire, by flood. The Maya calculated cosmic cycles stretching back millions of years as if they remembered something we've forgotten. What if these aren't myths at all? What if they're the last echoes of something real? Fragments of historical memory passed down through oral traditions that stretch back to humanity's dawn. What if they're trying to warn us? Here's what haunts the deepest nightmares of paleontologists. Fossilization is impossibly rare. Less than one organism in a billion ever becomes a fossil. Think about that. For every dinosaur bone in a museum, a billion others rotted away without leaving a trace. Entire species lived and died in the gaps between fossils, invisible to science, erased by time's cruel accounting. Tyrannosaurus rex ruled North America for millions of years, yet we've found fewer than 50 partial skeletons. 50! From millions of individual animals across eons of time, if we can barely preserve the bones of creatures weighing 7 tons, what hope do the delicate artifacts of civilization have? Cities crumbled to dust. Metal rusts to nothing. Wood rots. Paper dissolves. Even stone, our most permanent creation, weathers to sand under the patient assault of wind and rain. Look at the pyramids, humanity's greatest monuments to permanence. After just 5,000 years, they're already dissolving. Their smooth limestone casings stolen by medieval builders, their perfect edges worn soft by desert storms. In 10 million years, they'll be hills of rubble. In 10 million? Not even that. If our greatest works can't survive 10,000 years of weather, how could we possibly detect a civilization from 10 million years ago? But Adam Frank and Gavin Schmidt know something the rest of us don't. Something that changes everything. Civilizations may vanish, but chemistry is forever. Deep in ocean sediments and ice cores, Earth keeps chemical records that span millions of years. Carbon isotopes, oxygen ratios, trace elements that tell stories of ancient atmospheres, prehistoric climates, and events that shook the world. When we burn fossil fuels, we're not just releasing carbon dioxide, we're writing our signature into the geological record. The specific isotopic ratios of industrial carbon are different from natural sources. Unique, unmistakable.
Future geologists will find this spike in the rock layers and know exactly when humanity learned to burn coal and oil. They'll see how we changed the chemistry of the entire atmosphere in just 2 centuries, a geological instant that will echo through deep time forever. But here's the terrifying question Frank and Schmidt are asking. What if similar spikes already exist in the geological record? What if we're not the first species to discover fire, to smelt metals, to burn carbon on an industrial scale? What if the chemical signatures we're leaving behind aren't the first? Schmidt pulls up data from the Paleocene-Eocene thermal maximum, a mysterious warming event that occurred 56 million years ago. In the span of just 20,000 years, global temperatures spiked by 10 degrees Fahrenheit. Ocean acidity increased. Ice caps melted. The carbon isotope ratios in rocks from this period show massive releases of fossil carbon into the atmosphere. The pattern is identical to what we're doing today. Identical. The official explanation is volcanic activity, massive eruptions releasing carbon from underground reservoirs. But Frank stares at the data and asks the question that keeps him awake. What if it wasn't volcanoes at all? What if it was them? What if 56 million years ago, another intelligent species discovered coal and oil and began burning fossil fuels on an industrial scale? What if they had their own industrial revolution, their own climate crisis, their own moment of reckoning with the consequences of their technology? What if they failed to solve it in time? The chemical signature in the rocks could be their obituary, the last testament of a civilization that burned too bright and died in the fires of their own making. By the time the climate stabilized, they were gone. Their cities buried, their bones dissolved, their entire existence reduced to a thin layer of carbon-enriched sediment that we mistake for volcanic activity. Frank's hands tremble as he types his conclusions. If this hypothesis is correct, then every assumption about human uniqueness crumbles. We're not the first to discover fire, the first to build cities, the first to split the atom or reach for the stars. We are just the latest in a long line of species who thought they were special, who believed they were chosen, who convinced themselves they were the pinnacle of evolution right up until the moment they weren't. Earth has been running experiments in intelligence for hundreds of millions of years. Most failed quickly, some lasted longer. A few might have achieved genuine technological sophistication before succumbing to climate change, resource depletion, or cosmic catastrophe. The evidence of their existence has been ground to dust by glaciers, dissolved by acid rain, subducted into the mantle by tectonic forces. Only the faintest chemical whispers remain, signatures so subtle that we lack the wisdom to recognize them for what they truly are. We scan the stars searching for alien intelligence, never imagining that we might be standing on the graves of our predecessors. The Silurian hypothesis doesn't claim that ancient civilizations definitely existed. It asks a more disturbing question. If they had existed, would we be able to detect them? The answer appears to be no, which means the absence of evidence is not evidence of absence. It means that the silence of deep time might be hiding secrets that would fundamentally change our understanding of life, intelligence, and our own place in the cosmic order.
In termite colonies across Africa, massive mounds rise from the savanna. Complex structures with ventilation systems, fungus gardens, and architectural sophistication that rivals human engineering. The colonies can last for decades, housing millions of individuals in perfect harmony. But when the colony dies, the mounds erode quickly. Within a few centuries, they're gone, dissolved by rains, scattered by winds, reclaimed by the patient earth. Future archaeologists studying the African savanna might find no trace of these remarkable civilizations. From the perspective of deep time, human cities look exactly like termite mounds, temporary, fragile, ephemeral. What remains of the greatest human achievements after 10 million years of weather, earthquakes, and continental drift? What trace would survive the patient recycling of stone, the endless grinding of glaciers, the slow consumption of coastlines by rising seas? The honest answer is almost nothing. Which means that if other civilizations rose and fell in Earth's deep past, we would be blind to their existence. The geological record would have erased them as completely as if they never existed at all. Tonight, as you lie in bed listening to the familiar sounds of human civilization, cars humming on distant highways, planes crossing overhead, the electrical hum of modern life, remember this. The mountains around your city have risen and fallen dozens of times. The continents have drifted thousands of miles from where they sit today.
The very atoms in your body have been recycled through countless other forms of life across billions of years. You are temporary. Your species is temporary. Your civilization is a brief flicker in the vast darkness of deep time. But that doesn't make you less important. It makes you more precious than diamonds, rarer than gold, more fragile than snowflakes melting on warm stone. Because if Frank and Schmidt are right, if civilizations can rise and fall without leaving permanent traces, then consciousness itself might be the universe's most endangered phenomenon. Intelligence might emerge for brief moments across cosmic time, burn bright with the fire of discovery and creation, then fade back into the patient silence of stone and star. We might be alone in the universe, not because intelligence never evolves elsewhere, but because it never lasts long enough to find its neighbors. Or we might be the inheritors of a legacy we don't even know exists, the latest chapter in a story that began millions of years ago, written by minds we can't imagine, in languages we can't read, on pages that have long since crumbled to dust. The only way to know is to learn what truly survives the crushing weight of deep time and what gets erased forever. Walk with me through Manhattan, but not the Manhattan you know, the Manhattan of 10 million years from now. You're standing where Times Square once blazed with 1 million lights, where yellow cabs honked through concrete canyons, where 8 million souls lived and loved and dreamed. Now, there's only wind. Red sandstone stretches to the horizon. Ancient dunes drift where skyscrapers once pierced the sky. The Hudson River carved a new channel centuries ago, leaving fossil seashells where Wall Street traders once screamed buy and sell orders into phones. You kick at the sand beneath your feet, searching for some trace, some whisper of the greatest city humanity ever built. Your boot strikes something hard. You brush away the grit with trembling fingers.
A chunk of concrete, weathered smooth as river stone. This is all that remains of 8 million human stories, of Broadway shows and hot dog vendors and subway musicians, of first kisses on Brooklyn Bridge and marriage proposals in Central Park, of children taking their first steps in playgrounds that have been sand for millennia. All of it gone. This is the terrifying arithmetic of deep time, and it's happening to every trace we leave behind faster than you think. The Earth is a hungry beast that devours its own history. Every mountain range is temporary. The Himalayas, those seemingly eternal giants, are babies in geological terms, a mere 50 million years old and already being ground down by wind and rain at a rate of several millimeters per year. Give them another 100 million years and they'll be rolling hills. In 500 million years, not even that. The Appalachians were once taller than the Himalayas. Now they're gentle slopes covered in forests, their ancient peaks worn down to nubs by 500 million years of weather. What will the Rockies look like in 200 million years? What will remain of the Alps? Nothing. Not even the memory of their majesty. This is Earth's cruel recycling program. Erosion strips mountains grain by grain. Rivers carry the debris to the sea. Ocean floors accumulate sediment for millions of years, then get shoved back into the planet's molten interior by tectonic forces. The rock that forms new mountains contains the atomized remains of previous mountain ranges, previous continents, previous worlds. Your morning coffee mug might contain atoms that once formed the backbone of a Tyrannosaurus rex. The calcium in your bones might have built coral reefs when Africa and South America were still joined at the hip. You are literally made of recycled worlds. And those worlds remember nothing of what they once were. Let's talk about humanity's greatest monuments, our pyramids, our cathedrals, our desperate attempts to cheat mortality with stone and steel. The Great Pyramid of Giza has stood for 4,500 years and we marvel at its permanence. But look closer. The smooth limestone casing that once made it gleam like a jewel in the desert is gone, stripped away by medieval builders who needed stone for Cairo's mosques and palaces. The perfect edges have weathered to rough steps. The precision-cut blocks show gaps where mortar has dissolved. 4,500 years, and already our greatest monument to eternity is crumbling. Compare that to the lifespan of a mountain. Compare that to the 165 million years that dinosaurs ruled the Earth. The pyramid hasn't even lasted 1/10,000th of the dinosaur era, and it's already falling apart. What about modern structures? The engineers who built the Empire State Building estimated it would last 500 years with proper maintenance. Without maintenance, if humans vanished tomorrow, wind and rain would bring it down in decades. The steel would rust, the concrete would crack and spall. By the year 3000, it would be a pile of rubble. By the year 100,000, not even that. Skyscrapers, for all their height and strength, are more fragile than flowers. At least flowers leave pollen in the fossil record. Here's what keeps paleontologists awake at night. We know almost nothing about the history of life on Earth. Think about that statement. Let it sink in like ice water in your veins. Dinosaurs dominated the planet for 165 million years, longer than any other group of land animals in Earth's history. They evolved into thousands of species, filled every ecological niche, and developed complex social behaviors, and some may have been more intelligent than we give them credit for. Yet we've found fossils from fewer than 1,000 dinosaur species, out of thousands that must have existed. From 165 million years of evolutionary experimentation, we have preserved fragments representing less than 1% of the story. Most dinosaur fossils are just single bones or teeth. Complete skeletons are so rare that each discovery makes international headlines. The mighty Tyrannosaurus rex, the most famous predator in history, is represented by fewer than 50 partial skeletons worldwide. 50 individuals out of millions that must have lived and died across 2 million years of T-Rex dominance. The mathematics are horrifying. Fewer than one organism in a billion ever fossilizes. The conditions have to be perfect: rapid burial in sediment, low oxygen to prevent decay, the right chemistry to replace organic material with stone. Most creatures die and rot on the surface, their bones scattered by scavengers, their flesh consumed by bacteria, their very existence erased within years. If we can barely preserve the 7-ton skeletons of apex predators, what hope do the delicate artifacts of intelligence have? But chemistry? Chemistry is different. Chemistry is forever. Dr. Lee Kump stands in his Pennsylvania State University laboratory, surrounded by machines that can detect individual atoms in ancient rock. He's holding a core sample drilled from ocean sediments that formed 56 million years ago during that mysterious warming event called the Paleocene-Eocene thermal maximum. The rock looks ordinary, gray limestone flecked with tiny fossils, but Kump's instruments reveal secrets invisible to the naked eye. Carbon isotope ratios that tell stories of ancient atmospheres, oxygen signatures that whisper of prehistoric temperatures, trace elements that map the chemistry of vanished worlds. The Earth keeps perfect chemical records, Kump explains, his voice barely containing his excitement. Temperatures, atmospheric compositions, major climate events, it's all written in the rocks if you know how to read the language. This is how we know that 252 million years ago, massive volcanic eruptions in Siberia pumped so much carbon dioxide into the atmosphere that 96% of all marine species went extinct. The chemical signature of that catastrophe is preserved in rocks around the world, a thin layer of carbon-enriched sediment marking the boundary between the Permian and Triassic periods. It's how we know that 66 million years ago, an asteroid impact filled the atmosphere with vaporized rock and triggered global wildfires. The chemical fingerprint of that disaster, elevated levels of iridium, a rare element common in asteroids, forms a distinct layer in the geological record. And it's how we know that something very strange happened 56 million years ago during the PETM. The Paleocene-Eocene thermal maximum wasn't supposed to exist. For millions of years, Earth's climate had been stable, warm but stable. Then, in what geologists call an instant, about 20,000 years, less than a blink in geological time, global temperatures spiked by 10 degrees Fahrenheit. Ice caps melted, sea levels rose, tropical forests grew at the North Pole. Ocean acidity increased so dramatically that deep-sea creatures with calcium carbonate shells simply dissolved. The chemical signature in the rocks tells a clear story. Massive amounts of carbon poured into the atmosphere. But where did it come from?
The official explanation points to volcanic activity. Massive eruptions in the North Atlantic, they say. Underground coal seams ignited by lava flows. Natural processes releasing stored carbon at an unprecedented rate. But Dr. Kump stares at the data and sees something troubling. The carbon isotope ratios don't quite match what you'd expect from pure volcanic activity. The rate of release seems too fast, too coordinated, too deliberate. What if the PETM wasn't natural at all? What if it was industrial? What if 56 million years ago, another intelligent species discovered fossil fuels and began burning them at a rate that fundamentally altered the planet's climate? What if they had factories, power plants, internal combustion engines? What if they faced their own version of climate change and failed to solve it in time? The chemical signature would be identical to what we see today. The timeline would match our own industrial revolution, a geological instant of carbon release followed by long-term climate disruption. Their civilization would have collapsed as temperatures soared and ecosystems failed. Their cities would have been buried by rising seas and shifting sands. Their bones would have dissolved in acidified oceans. Within a few million years, nothing would remain but that thin layer of carbon in the rock, their final testimony written in chemistry instead of stone. This is the genius of the Silurian hypothesis. It doesn't require us to find alien cities or fossilized spaceship parts. It asks a simpler, more terrifying question. If ancient civilizations existed, what traces would actually survive? The answer is almost nothing except chemistry. Industrial activity leaves specific fingerprints, unusual isotope ratios, synthetic compounds that don't occur in nature, elevated levels of rare elements. These signatures can persist in sedimentary rocks for hundreds of millions of years, long after every building has crumbled and every bone has dissolved. We are creating such signatures right now. Future geologists will find our layer in the rock record: elevated carbon dioxide, plastic particles, radioactive isotopes from nuclear testing, metals refined in concentrations that could never occur naturally. They'll know that something unusual happened in the early 21st century, something that changed the chemistry of the entire planet in just a few centuries. But here's the spine-chilling question. What if similar layers already exist in rocks we haven't studied carefully enough? What if the chemical signatures we're leaving behind aren't the first? Dr. Sarah Raquel pulls up satellite images of Easter Island on her computer screen. Once, this remote speck in the Pacific supported a thriving civilization. The Rapa Nui people carved nearly 1,000 massive stone statues and transported them across the island using sophisticated engineering techniques that archaeologists still don't fully understand. But by the time European explorers arrived in 1722, the civilization was gone. The forests had been cleared, the soil had eroded, the population had crashed from perhaps 15,000 to fewer than 2,000 survivors clinging to life on a degraded landscape. The Moai statues remain, weathered but recognizable after just a few centuries. But everything else, the houses, the boats, the complex social structures that created those monuments, has vanished. Only the stone endures, and even that is slowly dissolving under the assault of Pacific storms. This is what happens to civilizations, Raquel says, her voice heavy with implication. They rise, they peak, they collapse, and within a few generations, only fragments remain. If Easter Island had been abandoned for 10,000 years instead of 300, would we even know a sophisticated culture once existed there? Probably not. The statues would still stand. Stone is durable on human timescales. But the organic evidence of civilization would be gone. No wooden tools, no rope, no cloth. No bones in good enough condition to reveal the full scope of their achievements. And Easter Island collapsed just 300 years ago. What about civilizations that might have collapsed 300,000 years ago? Or 3 million years ago? Or 30 million? What trace would remain? The Earth's crust is a graveyard of forgotten worlds. Every sedimentary rock began as particles eroded from previous landscapes. The limestone forming today in Caribbean seas contains the pulverized remains of ancient coral reefs, themselves built from the skeletons of creatures that lived and died when dinosaurs ruled the land. Sandstone preserves the patterns of wind-blown dunes from deserts that vanished before mammals evolved. Shale holds the compressed remains of mud that accumulated on seafloors when the continents had completely different shapes. Each layer tells a story, but it's a story filtered through millions of years of burial, compression, heating, and chemical alteration. The details get lost, the subtleties disappear. Only the broadest patterns survive. A future geologist studying rocks from our era will find elevated carbon dioxide levels and unusual isotope ratios. They might conclude that volcanic activity was unusually intense during the early 21st century, or that asteroid impacts were common, or that some other natural process was responsible for the chemical anomalies. They might never suspect that intelligence was the cause. This is the humbling truth about deep time. It erases not just our monuments and our bones, but even the memory that we were ever intelligent at all. The Earth will record that something unusual happened during our brief reign, but it will not remember that we built cities, or wrote symphonies, or split atoms, or dreamed of touching the stars. Chemistry survives. Intent does not. Yet chemistry can tell us more than we might expect. Deep in the Greenland ice sheet, scientists drill cores that preserve a year-by-year record of atmospheric conditions going back 800,000 years. Each annual layer captures the exact composition of ancient air, carbon dioxide levels, methane concentrations, volcanic dust, even cosmic debris from meteor impacts. The ice reveals a planet in constant flux. Ice ages come and go like slow breathing.
Volcanic eruptions spike the atmosphere with sulfur. Forest fires leave signatures of smoke and ash. The chemical record is remarkably detailed and surprisingly complete. But it only goes back 800,000 years, an eye blink in the 4.5 billion-year history of Earth. And it only preserves atmospheric chemistry, not the activities that might have caused unusual atmospheric changes. Ocean sediments preserve longer records, stretching back tens of millions of years in some locations. But the resolution is lower. Each centimeter of sediment might represent thousands of years of accumulation. Brief events get averaged out. Sharp spikes get smoothed into gentle curves. A civilization that burned fossil fuels for just a few centuries might leave only the faintest trace in such records. A slight elevation in carbon isotopes that could easily be attributed to natural causes. We're learning to read these chemical signatures with increasing sophistication, but we're still geological babies trying to interpret a library written across billions of years. How much are we missing? How many stories are hidden in the chemistry of rocks we haven't studied or studied with instruments not sensitive enough to detect the subtle fingerprints of ancient intelligence? The search for these fingerprints is just beginning. Dr. Gavin Schmidt pulls up global maps showing where his team has collected samples for isotope analysis. Red dots mark locations where they found detailed chemical records going back millions of years. The dots are scattered across the planet, but clustered around universities and research stations. Not because those are the only places with interesting geology, but because those are the only places with scientists and funding to do the work.
Vast regions of Africa, Asia, South America, and Antarctica remain virtually unstudied. Ocean basins covering 70% of the planet's surface have barely been sampled. Mountain ranges, deserts, and polar regions hold rocks that could contain the chemical diaries of previous civilizations, but we lack the resources to read them all. We've analyzed maybe 0.1% of the potentially relevant rock record, Schmidt admits. It's like trying to understand a million-page book by reading a single paragraph. We might be missing entire chapters. Each new study reveals surprises. Chemical spikes that don't match known natural events. Isotope ratios that seem too unusual to be coincidental. Trace elements in concentrations that demand explanation. Most are eventually linked to volcanic activity, asteroid impacts, or other familiar geological processes, but some remain mysterious. Some force scientists to propose increasingly exotic natural explanations or to quietly file them away as anomalies to be studied when better instruments become available. What if some of those anomalies aren't natural at all? What if they're the fading chemical echoes of civilizations that burned bright and died long before our ancestors learned to control fire? The clock is ticking. Every day, erosion and tectonic activity erase more of the rock record. Precious sedimentary layers that preserved chemical signatures for millions of years get ground up by glaciers or melted in the planet's interior. Continental drift carries potential fossil sites into subduction zones where they disappear forever into the molten mantle. We're racing against time to read the chemical diary of deep time before the pages crumble to dust. But there's another clock ticking too, the clock of our own civilization's survival. If we are indeed the latest in a series of intelligent species to evolve on Earth, then we're also the latest to face the challenges that destroyed our predecessors. Climate change, resource depletion, environmental collapse. The same forces that might have reduced previous civilizations to thin layers of carbon in the rock record. The difference is that we know we're writing our own chemical signature. We can see the elevated carbon dioxide levels in real time. We can measure the rate at which we're changing the planet's atmosphere and oceans. We have the scientific tools to understand what we're doing and possibly to do something about it. But understanding and acting are different things. Knowledge and wisdom are not the same. Previous civilizations might have had similar knowledge. They might have known that their activities were changing the climate, altering ocean chemistry, triggering mass extinctions. They might have held conferences and signed agreements and made promises to future generations. But they're gone now, reduced to chemical whispers in sedimentary rock. The question that will determine our own fate is simple. Will we learn from their example, or will we become another mysterious isotope spike for future archaeologists to puzzle over? Tonight, walk outside and look up at the stars. Those points of light have been shining down on this planet for billions of years. They've witnessed the rise and fall of countless species, the slow dance of continents, the birth and death of entire ecosystems. What have they seen that we cannot remember? How many times has intelligence awakened on this small blue world, looked up at those same stars, and wondered if it was alone in the universe, never imagining that the answer was buried beneath its feet in chemical signatures too subtle to detect? The search for these ancient fingerprints continues. In laboratories around the world, scientists are developing new techniques to read the chemical language of deep time, more sensitive instruments, better methods for analyzing isotope ratios,
improved ways of distinguishing natural processes from artificial ones. Each breakthrough brings us closer to answering the ultimate question: are we the first technological civilization to evolve on Earth, or simply the first to ask? The rocks hold the answer. Hidden in their chemistry are the secrets of deep time, stories of worlds we never knew existed, civilizations that rose and fell in the vast darkness before human memory began. All we have to do is learn to read the language they left behind. But that language is written in mysteries older than mountains, riddles more ancient than oceans. And deciphering it will require us to confront truths about the nature of intelligence, the fragility of civilization, and our own place in the cosmic order. Truths that might change everything we thought we knew about the past, and everything we believe about the future. History teaches us one powerful lesson: nothing lasts forever. Not empires, not kings, not even entire civilizations. But stories only survive when they're passed on. So if you've made it this far, don't just be a silent traveler through time. Hit that like button, subscribe, and turn on notifications, because if you don't, this story may vanish into the noise, just like the civilizations we speak of. Don't let it be forgotten. Back to our story. The old priest's eyes burn with fever as he whispers the secret across the table. His name is Sonchis, high priest of Sais in the Nile Delta, keeper of Egypt's most ancient memories. The year is 560 BCE, and seated across from him is Solon, lawgiver of Athens, traveler, seeker of wisdom from the oldest civilization on Earth. "You Greeks are children," Sonchis hisses, his weathered hands trembling as they trace hieroglyphs carved in stone. "You know nothing of the deep past, nothing of what came before." Solon leans forward, candlelight dancing across his face. He has traveled 1,000 miles to hear these words, drawn by rumors that Egypt's priests guard memories stretching back beyond the flood, beyond the dawn of known history. "Tell me," Solon whispers. And so, the priest begins a story that will haunt humanity for the next 2,500 years. Beyond the Pillars of Hercules, Sonchis says, there once lay an island larger than Libya and Asia combined. The people who lived there possessed power beyond imagination, bronze that gleamed like gold, ships that could cross any sea, buildings that touched the sky. The priest's voice drops to barely audible. They grew proud, they forgot wisdom, they made war against all free peoples. His eyes meet Solon's across the flickering flame. In a single day and night of terrible earthquakes and floods, the island sunk beneath the waves. It vanished completely, leaving only impassable mud where once a mighty civilization had ruled the oceans. Solon feels ice in his veins. When? He manages to ask. 9,000 years before your birth, the priest replies. 9,000 years. This is how the story of Atlantis entered human consciousness, not as myth, but as history, not as fantasy, but as the preserved memory of something that actually happened in the deep past. But what if Sonchis wasn't lying? What if the Egyptian priests really did preserve memories that stretched back 11,500 years, deeper than the oldest known cities, older than agriculture itself? What if Atlantis was real? The mathematics are staggering. 9,000 years before Solon means 11,500 years before today. That places the destruction of Atlantis right at the end of the last ice age, a period of unprecedented global catastrophe when sea levels rose by 400 feet, entire continents disappeared underwater, and climate zones shifted across thousands of miles.
It was the most dramatic environmental change in human history. Coastal plains that had supported hunter-gatherer populations for thousands of years vanished beneath the waves. River valleys that had carved stable channels for millennia were drowned by meltwater floods. The geography of the entire planet changed in just a few centuries. If advanced civilizations had existed during the Ice Age, this would have been their apocalypse. Dr. Graham Hancock stands on the underwater ruins off the coast of Japan, 80 feet beneath the Pacific's surface. The structures around him, massive stone terraces, perfectly aligned blocks, step pyramids rising from the seafloor, were carved when this area was dry land, before the melt, before the flood. Mainstream archaeology refuses to acknowledge what we're looking at, Hancock says through his diving mask, his words translated into bubbles that rise toward the distant surface. They claim these are natural rock formations, but nature doesn't create right angles and perfect geometric alignments. The Yonaguni Monument, as it's come to be known, displays clear evidence of human modification. Tool marks, drainage channels, stairways cut into living rock. If it's artificial, and the evidence suggests it is, that it was built by people who had sophisticated stone-working technology more than 12,000 years ago. People who were supposedly still living in caves and hunting mammoth with spears. But the monument isn't alone. Underwater structures have been discovered off the coasts of India, Malta, Cuba, and the Bahamas, all dating to periods when those areas were above sea level, all suggesting that human civilization might be far older and far more advanced than we ever imagined. What if the flood stories aren't myth at all?
What if they're cultural memories of real events that destroyed real civilizations at the end of the Ice Age? The stories are everywhere. Every culture, every continent, every isolated people who never had contact with each other until European explorers connected the dots. In ancient Mesopotamia, they carved the Epic of Gilgamesh into clay tablets. For 6 days and 7 nights the flood swept over the land. The hurricane raged. The tempest of the flood bellowed like a woman in travail. In Hebrew Bible, all the fountains of the great deep were broken up, and the windows of heaven were opened, and the rain was upon the earth 40 days and 40 nights. In Hindu scriptures, Vishnu warns the sage Manu of a coming deluge that will destroy all life. He provides a great ship and commands Manu to save representatives of every species. Indigenous peoples across the Americas tell identical stories, despite being separated by thousands of miles and thousands of years until European explorers connected the dots. The Hopi describe previous worlds destroyed by ice, by fire, by flood. The Maya speak of cosmic cycles where entire civilizations are washed away to make room for new ones. Aztec legends tell of 4 previous worlds, each ending in catastrophe. The oral traditions of Australian Aborigines, unchanged for 40,000 years, describe a time when the sea levels rose and swallowed the lands where their ancestors lived. They point to areas now underwater and named the rivers and hills that once existed there. Modern bathymetric surveys confirm the accuracy of these memories. How could isolated cultures on opposite sides of the planet develop identical flood myths unless they were describing the same real event? But the most disturbing stories come from civilizations that claim to remember cycles, endless repetitions of rise and fall, birth and death, creation and destruction, stretching back millions of years. Hindu cosmology describes vast wheels of time called yugas, 4 ages that repeat eternally. Satya Yuga, the Golden Age; Treta Yuga, the Silver Age; Dwapara Yuga, the Bronze Age; and Kali Yuga, the Dark Age, of ignorance and suffering. Each cycle, one Mahayuga, lasts 4.32 million years. Think about that. Ancient Sanskrit texts describe cosmic cycles lasting millions of years, as if the people who wrote them had witnessed such cycles multiple times, as if they remembered civilizations rising and falling across geological timescales. The Puranas speak of previous kalpas, cosmic days lasting billions of years during which countless civilizations evolved, flourished, and vanished. The current universe is supposedly the second of 2 Parardas, cosmic lifetimes, each containing 311 trillion years. These numbers are so vast that modern cosmologists didn't reach similar estimates for the age of the universe until the 20th century. Yet somehow, Bronze Age Sanskrit texts got remarkably close to the actual figure. How could ancient priests in the Indus Valley have conceptualized timescales that humanity wouldn't rediscover until we developed nuclear physics and space telescopes? Unless they weren't guessing. Unless they were remembering. The Maya calculated time with obsessive precision that borders on the supernatural. Their long count calendar tracks cycles within cycles within cycles, reaching back to a creation date that translates to August 11th, 3114 BCE in our calendar. But that's just one cycle. The Maya conceived of time as an endless spiral of repeating patterns, with some cycles lasting thousands of years and others stretching across millions. They tracked the precession of the equinoxes, a 26,000-year wobble in Earth's rotation that causes the position of stars to shift slowly across centuries. This is an incredibly subtle astronomical phenomenon that requires sophisticated observations spanning many generations to detect. The Maya not only detected it, they incorporated it into their calendar as a fundamental organizing principle. But they went further, much further. Maya codices describe previous worlds that ended in catastrophe, followed by new worlds populated by different types of beings. The Popol Vuh tells of wooden people who were destroyed by flood, followed by mud people who melted in the rain, followed by the current world of flesh and blood. Each world lasted for thousands or millions of years. Each ended when the gods grew tired of their creations and decided to start over. The precision of Maya timekeeping suggests they weren't just recording recent history, they were tracking patterns that repeated across deep time, as if they had witnessed multiple cycles of creation and destruction, as if they were recording events that stretched back far beyond the supposed dawn of human civilization. Dr. Jose Arguelles spent decades decoding Maya calendar mathematics and reached a disturbing conclusion. The Maya weren't just tracking time, they were tracking the rise and fall of consciousness itself. They had mapped the cycles by which intelligence emerges, develops technology, destroys itself, and begins again. If Arguelles is right, then Maya calendars aren't just ancient astronomy, they're the preserved memory of previous technological civilizations that rose and fell according to predictable patterns. Patterns we might still be following today. But the most chilling evidence comes from places that shouldn't exist at all. Göbekli Tepe squats on a hilltop in southeastern Turkey like a stone riddle that makes archaeologists weep. Massive megalithic circles arranged with mathematical precision, decorated with sophisticated carvings of animals and abstract symbols that seem to tell a story we can't read. The site is 11,500 years old. 11,500 years, the same time frame when the last ice age ended and sea levels rose by hundreds of feet, when human civilization was supposedly limited to small bands of hunter-gatherers scratching out a living in caves. Yet someone organized thousands of people to quarry, transport, and erect stone blocks weighing up to 16 tons each. Someone had advanced knowledge of astronomy, geometry, and engineering. Someone created the world's first temple complex and then deliberately buried it under tons of rubble, as if they were trying to preserve it from some coming catastrophe.
The official explanation is that hunter-gatherers built Göbekli Tepe during idle time between hunts, somehow developing advanced construction techniques without any precedent or practice. Then, for reasons unknown, they decided to bury their masterpiece and walk away. This strains credulity past the breaking point. Dr. Klaus Schmidt, the archaeologist who excavated Göbekli Tepe, reached a different conclusion. What we're seeing here is the death throes of a much older, much more sophisticated civilization. The people who built this weren't primitive hunter-gatherer learning to farm. They were the last survivors of something far more advanced, trying to preserve their knowledge before the final collapse. Schmidt died before he could prove his theory, but the evidence keeps mounting. Ground-penetrating radar reveals dozens more megalithic circles still buried around the site. Each one appears to be older and more sophisticated than the last, as if the builder's skills were declining rather than improving over time. As if we're looking at the end of something, not the beginning. The anomalies multiply faster than archaeologists can explain them away. The Antikythera mechanism, a bronze computer from ancient Greece that calculated the movements of planets with shocking accuracy, represents technology that wouldn't be reinvented until the 18th century.
The Baghdad Battery, a clay jar containing copper and iron components that generates electric current when filled with acidic liquid, suggests ancient knowledge of electrochemistry that mainstream history claims didn't exist until the 1800s. The precision-cut stone blocks of Sacsayhuaman in Peru fit together so perfectly that you can't slide a knife blade between them. Yet they were supposedly assembled by people who had never invented the wheel. The underground chambers of the Hypogeum in Malta create acoustic effects that amplify specific frequencies while dampening others, as if the builders understood resonance physics that we're only now rediscovering. Each anomaly can be dismissed individually. Ancient Greeks were clever with gears. Medieval alchemists experimented with primitive batteries. Inca stonemasons were unusually skilled. Neolithic builders stumbled onto acoustic principles by accident. But taken together, they suggest something far more disturbing: that advanced technical knowledge has appeared and disappeared multiple times throughout human history. That civilizations have risen to sophisticated heights, collapsed into darkness, then slowly clawed their way back up the ladder of progress, only to fall again. As if there's a cycle, a pattern, a recurring tragedy that plays out across millennia. Dr. Robert Schoch runs his fingers along the weathered limestone blocks of the Sphinx, feeling the unmistakable signatures of water erosion carved deep into the stone. The problem is simple. The Sphinx sits in the middle of the Sahara Desert, one of the driest places on Earth. It hasn't seen substantial rainfall for thousands of years, yet the erosion patterns on its body could only have been created by centuries of heavy precipitation. The last time this area experienced that kind of sustained rainfall, Dr. Schoch explains, was at the end of the last ice age, around 10,000 to 12,000 years ago. The geological evidence is unambiguous. This pushes the Sphinx back thousands of years earlier than mainstream Egyptology claims. Instead of being built by Pharaoh Khafre around 2500 BCE, it would have been carved during the Younger Dryas period, when Egypt was green and lush, fed by monsoons that no longer reach the region. But if the Sphinx is 12,000 years old, who built it? According to Orthodox archaeology, humans at that time were just beginning to develop agriculture. They lived in small settlements and had barely learned to work stone. They certainly hadn't developed the sophisticated techniques needed to carve a 240-foot-long monument from solid bedrock. Unless there was an earlier, more advanced civilization, a civilization that existed before the floods, before the droughts, before the great climate change that turned Egypt from a verdant paradise into a desert wasteland.
The ancient Egyptians themselves claimed they inherited their monuments from the gods, beings called the Neteru, who ruled Egypt during the Zep Tepi, the first time. Egyptian texts describe this golden age as a period when divine beings possessed advanced technology and profound wisdom. What if the Zep Tepi wasn't myth? What if it was the preserved memory of a pre-flood civilization that actually existed in the Nile Valley when it was still green? A civilization that built the original Sphinx as part of a vast complex that was later inherited, restored, and claimed by dynastic pharaohs who had forgotten the true age of their monuments. The evidence accumulates like sediment in an ancient lake bed, layer upon layer of anomalies that don't fit the standard timeline of human development. Underwater pyramids off the coast of Cuba, sitting 2,000 feet below the surface in areas that haven't been dry land for millions of years, unless the catastrophic flooding at the end of the Ice Age was even more dramatic than we think. Stone circles in Turkey and Armenia that predate Stonehenge by thousands of years, arranged according to astronomical alignments that suggest sophisticated understanding of celestial mechanics.
Cave paintings in France and Spain that depict animals with an accuracy and artistic sophistication that rivals modern wildlife photography, created by people who supposedly had no artistic tradition or cultural precedent. Megalithic walls in Peru, built with stones weighing hundreds of tons, transported from quarries dozens of miles away and fitted together with tolerances measured in fractions of inches. Maps from the Middle Ages that show the Antarctic coastline as it exists under the ice. Coastlines that haven't been visible for millions of years and weren't officially discovered until the 20th century. Each piece of evidence can be attacked individually. Misidentification, hoax, natural formation, coincidence. The critics have explanations for everything. But explanations and understanding are different things. When you step back and look at the pattern, the global distribution of advanced techniques, the consistent timelines, the matching flood stories, the cyclical cosmologies, a different picture emerges. A picture of human civilization that is far older, far more sophisticated, and far more fragile than we ever imagined. The Bronze Age collapse offers a terrifying preview of how quickly it can all disappear. Around 1200 BCE, the Eastern Mediterranean was home to a network of advanced civilizations. The Hittite Empire controlled much of modern Turkey. The Mycenaean Greeks ruled their island kingdoms with bronze weapons and written language. The Egyptians built pyramids and temples that still inspire awe today. Trade routes connected these civilizations across thousands of miles. They exchanged goods, ideas, and technologies. They had developed writing, metallurgy, astronomy, and mathematics. By any reasonable measure, they represented the pinnacle of human achievement. Then, in the span of just 50 years, it all collapsed. Cities were abandoned, palace complexes were burned, trade networks disappeared, writing systems were forgotten, entire populations vanished from the archaeological record as if they had never existed. The causes are still debated. Climate change, natural disasters, invasions by mysterious sea peoples, internal conflicts, systemic failure, but the result was unmistakable, a dark age that lasted for centuries. When civilization finally recovered, it had to rediscover techniques and knowledge that previous generations had taken for granted. The Bronze Age collapse wasn't unique. The Maya abandoned their greatest city seemingly overnight around 900 CE. The Angkor Empire in Cambodia, which built massive temple complexes that housed over 1 million people, vanished so completely that the jungle swallowed their capital for centuries. The Cahokia culture in North America, which built earthenwork pyramids larger than those in Egypt and supported populations that wouldn't be matched until Chicago was founded, disappeared without explanation, leaving only grass-covered mounds that European settlers mistook for natural hills.
Again and again throughout human history, sophisticated civilizations have risen to remarkable heights and then collapsed so completely that later peoples forgot they ever existed. What if this pattern extends much further back? What if the cycles of rise and fall that we can document over the last few thousand years are just the most recent repetitions of something that has been happening for millions of years? Indigenous wisdom traditions around the world preserve memories that mainstream academia refuses to take seriously. Aboriginal Australians speak of the dream time, a period when ancestor spirits shaped the landscape and established the laws that still govern their society. But the dream time isn't metaphorical. It's mapped onto real geography with precision that astounds modern anthropologists. Dreamtime stories describe the locations of water sources, seasonal migration routes, and natural resources across hundreds of thousands of square miles. They encode navigational information, botanical knowledge, and astronomical observations in narrative form that can be memorized and passed down unchanged for generations. Some of these stories describe events that can be dated geologically: rising sea levels that match the end of the Ice Age, volcanic eruptions that correspond to known geological events, impact craters that weren't officially discovered until satellite surveys in the 20th century. How could oral traditions preserve accurate memories of events that happened 10,000, 20,000, or even 40,000 years ago? Native American prophecies speak of cycles where the world is destroyed and reborn. The Hopi describe 4 previous worlds, each ending in catastrophe when humanity forgot its spiritual purpose and became obsessed with material technology. We are supposedly living in the 5th world now, and the prophecies suggest it too will end when people lose balance with the natural order, perhaps through environmental destruction or technological hubris. The specificity of these prophecies is disturbing. They describe gourds of ashes that can destroy entire cities, nuclear weapons, cobwebs in the sky that connect all people, the internet, houses in the heavens where people live separated from the earth, space stations. How could ancient prophecies accurately predict modern technology unless the people who created them had witnessed similar technology in previous cycles? Dr. Graham Hancock sits in his study, surrounded by thousands of books and artifacts collected from around the world. Maps spread across his desk show the locations of megalithic sites, underwater ruins, and geological anomalies that don't fit orthodox timelines. "He's looking at this backwards," he says, his voice heavy with implication. We assume human civilization began recently and has been progressing steadily toward greater sophistication. But what if it's cyclical? What if advanced civilizations have risen and fallen multiple times, each one leaving fewer traces than the last? Hancock traces his finger across a world map marked with red dots. Look at the pattern. Megalithic sites that require advanced engineering, astronomical alignments that demand sophisticated mathematics, flood stories that cluster around the same time frame. It's not random. It's the scattered remains of something that once connected the entire globe. His theory is elegant as it is disturbing, that a global maritime civilization existed during the Ice Age when sea levels were 400 feet lower and vast continental shelves provided stable land masses for cities and ports. This civilization developed advanced technology, mapped the entire world, and established trading networks that connected every continent. When the ice sheets melted and the floods came, most of their cities vanished beneath the waves. The survivors scattered to high ground and passed down what knowledge they could through myths, legends, and encoded traditions. Some of them became the mysterious teachers who appeared in ancient cultures around the world. Thoth in Egypt, Quetzalcoatl in Mesoamerica, Viracocha in the Andes, bringers of civilization who claimed to have come from across the sea.
Over thousands of years, the memory faded. The survivors' descendants forgot their true origins and began to see their ancestors as gods rather than men. But fragments of the original knowledge persisted in the form of myths, monuments, and mysterious techniques that seemed to appear fully formed without any development process. What we call the dawn of civilization might actually be the slow recovery from its greatest collapse. But even Hancock's theory might not go back far enough. What if the Ice Age civilization he describes was itself just the latest in a series of rises and falls? What if human intelligence has been cycling through phases of advancement and collapse for hundreds of thousands of years, or even longer? The geological record suggests that modern humans have existed for at least 300,000 years. That's 3,000 centuries, 12,000 generations, enough time for dozens of civilizations to rise, flourish, and disappear completely. For most of that period, we have almost no archaeological evidence of human activity. A few stone tools, some cave paintings, scattered bone fragments. The absence of evidence could mean our ancestors lived as simple hunter-gatherers for 290,000 years before suddenly inventing agriculture and writing. Or it could mean that the evidence of more sophisticated cultures has been erased by time, buried under ice sheets, drowned by rising seas, or ground to dust by geological processes we're only beginning to understand. The Silurian hypothesis suggests that even non-human civilizations might have existed in Earth's deep past and vanished without trace. If that's possible for alien species over millions of years, how much more possible is it for human civilizations over hundreds of thousands of years? We might be part of a cycle that has repeated many times before. Intelligence emerges, technology develops, civilizations rise. Something goes wrong, climate change, environmental collapse, cosmic catastrophe, or simple hubris, and everything falls apart. The survivors start over with fragments of memory disguised as myth. They slowly rebuild. They rediscover techniques their ancestors knew. They push further than before, thinking they're reaching new heights when they're really just climbing back up to levels previously achieved. Until something goes wrong again. The night sky holds secrets we're only beginning to glimpse. In 2019, astronomers discovered that Betelgeuse, one of the brightest stars in the constellation Orion, was dimming dramatically. For months, speculation ran wild that the red supergiant was about to explode in a supernova that would be visible during the day. The dimming turned out to be caused by a dust cloud, not stellar collapse. But the incident reminded us that our cosmic neighborhood is far more dynamic and dangerous than most people realize. Supernovae within 30 light-years of Earth would strip away the ozone layer and flood the planet with deadly radiation. Gamma-ray bursts from distant galaxies could sterilize entire hemispheres. Asteroid impacts, volcanic super-eruptions, and magnetic pole reversals occur regularly on geological timescales. Any of these events could end a technological civilization without leaving obvious traces for future archaeologists to find. A gamma-ray burst might kill most life on Earth, but leave buildings and monuments intact for millennia before normal decay processes erase them. Previous civilizations might have faced cosmic catastrophes we haven't experienced yet. Solar flares that fried all electronic technology. Asteroid impacts that triggered nuclear winters lasting decades. Nearby supernovae that forced survivors deep underground for generations. Such events would leave subtle signatures in ice cores and sediment layers, the same kind of chemical fingerprints that Adam Frank and Gavin Schmidt are learning to recognize in the geological record. But they would also reset technological progress to zero, forcing civilizations to begin again from scratch while retaining only fragmentary memories of what came before.
We are not the first technological civilization on Earth. We are the latest, the newest, the most recent experiment in consciousness and intelligence that this small blue planet has conducted. The others came before us, rose higher than we imagine, fell harder than we can comprehend, left traces so subtle that we mistake them for natural phenomena or dismiss them as coincidences. But they're not coincidences. They're breadcrumbs, clues, pieces of a vast puzzle that spans geological time and connects every anomalous artifact, every impossible monument, every flood story and creation myth into a single narrative. The narrative of intelligence struggling to survive in a universe that seems determined to erase all evidence of its existence. We have been here before. We have built cities and mapped the stars and split the atom and reached for immortality through technology. We have fallen and risen and fallen again like waves on an infinite shore. The question now is whether we can break the cycle, whether we can learn from the warnings preserved in myth and monument before we too become just another chemical anomaly in the geological record. whether we can become the first civilization to survive our own success. The answer lies not in the stars we dream of reaching, but in the stones beneath our feet, stones that remember everything, even when we forget ourselves. Tomorrow, we will discover what happens when civilizations fall, and what they leave behind for the next intelligence to find. The clocks stop at 11:47 p.m. Eastern Standard Time. Every human heart falls silent in the same terrible instant. 8 billion souls exhale their last breath as one, and Earth spins on through the cosmic dark. Indifferent, patient, eternal. What happens next will determine whether future archaeologists remember us as gods or never know we existed at all. Hour 1. The lights begin to fail. Without human operators to balance electrical grids, power plants automatically shut down to prevent overloads. Nuclear reactors insert their control rods as fail-safe systems activate. The aurora of artificial light that has crowned our planet for barely a century flickers and dies. Darkness reclaims the world. In space, the International Space Station continues its silent orbit, solar panels still collecting sunlight, computers still humming with the last automated commands. But without ground control, without mission updates, it's just an expensive tomb circling a graveyard planet. The satellites that connect our civilization, GPS networks, communication arrays, weather monitors, continue broadcasting to no one. Their signals propagate through empty spectrum, carrying the last digital whispers of human consciousness to an audience that no longer exists. Dogs howl in abandoned suburbs. Cats slink through silent apartment buildings. In zoos around the world, lions and elephants and great apes pace in enclosures that will never be cleaned again, never be restocked with food. The clock ticks toward midnight, but there's no one left to hear it chime. Day 7. Emergency systems are failing. Backup generators at critical facilities run out of fuel. Hospital life support systems power down with a final electronic wheeze. Nuclear power plants, designed to be fail-safe, shut themselves down completely as cooling systems lose power and containment protocols activate. Water pressure drops in cities worldwide as electric pumps stop working and gravity takes over. Sewage backs up in pipes that will never be cleared. Gas lines rupture without maintenance crews monitoring pressure systems. In pet stores and research facilities, animals die of thirst and starvation. The lucky ones escape when automatic doors lose power and spring open. Domestic animals begin to go feral, remembering instincts their ancestors carried before humans tamed them. But the plants keep growing. Grass pushes through sidewalk cracks. Vines begin their slow assault on abandoned buildings. Nature has been patient for so long, held back by constant human intervention. Now it starts to reclaim what was always its own.
The silence is broken only by wind through empty streets and the distant crash of windows falling from skyscrapers as thermal stress fractures the glass. Year 5. The cities are dying spectacular deaths. Without maintenance, water infiltrates building foundations, freeze-thaw cycles crack concrete and burst pipes. Steel rusts in the rain. Glass shatters from thermal expansion and seismic tremors. Wooden structures rot and collapse. Asphalt roads buckle and crack as plant roots find their way through the smallest fissures. Parking lots become meadows. Shopping malls turn into indoor forests as skylights fail and rain nurtures seeds carried by wind and birds. The Hoover Dam still holds back Lake Mead, but without operators to open spillways during flood season, water overtops the structure during heavy snowmelt.
The spillways erode, the concrete cracks. Within a century, it will fail catastrophically, unleashing a wall of water that will scour the Colorado River Valley clean. Wild animals flood into abandoned cities. Deer graze in Times Square. Wolves hunt in the ruins of Detroit. Mountain lions prowl through Beverly Hills mansions where movie stars once lived and dreamed of immortality. But domestic animals that survived the first chaotic years have gone completely wild. Dogs form packs and hunt in coordinated groups. Cats become apex predators in urban ecosystems where they have no natural enemies. Cattle and horses roam free across farmlands that slowly return to prairie and forest. But some human artifacts prove surprisingly durable. The bronze sculptures in Central Park will last millennia. The Mount Rushmore carvings will endure for hundreds of thousands of years, though weather will gradually soften their features until they're unrecognizable. And deep underground, in subway tunnels and storm drains, strange cavities will remain long after the buildings above have crumbled. Future geologists might puzzle over these hollow spaces in the rock record, perfect cylindrical tunnels that seem too regular to be natural formations. Century 25. The Great Erasure accelerates. Most wooden structures have completely rotted away. Steel and iron have rusted to powder. Aluminum has corroded and scattered. Even concrete, that seemingly eternal material, has cracked and crumbled under the relentless assault of water, ice, and plant roots. The skyscrapers are gone. The suburbs are gone. The highways are gone. Grass-covered mounds mark where cities once stood, indistinguishable from natural hills to casual observers. But the scars run deeper than surface structures. Vast mining operations have left open wounds in the landscape, strip mines, quarries, and excavations that will fill with sediment but remain visible from space for millions of years. The Three Gorges Dam, reinforced with modern engineering, might last 10,000 years before finally succumbing to the patient pressure of the Yangtze River. In remote locations, nuclear waste storage facilities present a different kind of permanence. The radioactive materials will remain hazardous for 10,000 years, 100,000 years, even 1,000,000 years. Future intelligent species might detect these radiation signatures and puzzle over their origin. Intense concentrations of artificial isotopes that don't occur in nature. Climate systems begin to rebalance without industrial carbon emissions. The extra CO2 in the atmosphere slowly gets absorbed by oceans and forests. Global temperatures stabilize and then begin to drop as the greenhouse effect weakens. Ice caps start to reform. Coastlines shift as sea levels fall. The planet begins to forget us. But not completely. Not yet. Millennium 10. Deep time starts to erase even our most permanent creations. The pyramids still stand, but their limestone blocks are weather-worn and cracked. The Great Wall of China has become a serpentine ridge of rubble stretching across a landscape that looks nothing like the China of our era. Rivers have changed course. Forests have replaced deserts. Deserts have replaced forests.
Mount Rushmore endurned. The faces are smooth, anonymous bumps on a granite cliff. The Hoover Dam is a concrete reef in a canyon lake. The bronze Statue of Liberty lies in pieces on the floor of New York Harbor, green with verdigris and slowly dissolving in salt water. But beneath our feet, more subtle traces persist. Urban archaeologists of the far future, if any exist, might notice oddly high concentrations of certain metals in sediment layers dating to the early 21st century. Lead from gasoline, aluminum from cans, platinum from catalytic converters.
These elements exist naturally, but not in the specific combinations and concentrations that industrial civilization produced. Plastic particles, those seemingly eternal pollutants, embed themselves in rock formations as sediments compact and harden. Future geologists might discover thin layers of polyethylene and polystyrene in rocks and wonder what natural process could have created such regular molecular chains. The isotopic signature of nuclear testing remains locked in tree rings and ice cores, an unmistakable fingerprint of artificial atomic fission. Future scientists with sophisticated instruments could detect these traces and know that someone, somewhere, had learned to split atoms, if they were wise enough to recognize what they were seeing. Million-year mark. Glaciers have come and gone multiple times, scouring continents clean and redistributing sediments across vast distances. Mountain ranges have risen and eroded. River valleys have carved new channels through landscapes that bear no resemblance to the world we knew. Even the climate has changed. Without human influence, natural cycles have reasserted themselves. Ice ages advance and retreat according to orbital mechanics that stretch across hundreds of thousands of years. Carbon dioxide levels fluctuate based on volcanic activity and the slow weathering of rocks. Most traces of human civilization are gone. The pyramids have eroded to unrecognizable mounds. The quarries and mines have filled with sediment. The cities have become fossil soil deposits, unusually dense concentrations of certain minerals that might catch the attention of a particularly observant geologist. But chemistry never forgets. Deep in ocean sediments, the isotopic signature of industrial carbon emissions creates a distinctive spike in the geological record. The ratio of carbon-12 to carbon-13 shifts dramatically in rocks that formed during the late 20th and early 21st centuries. The pattern is unmistakable to anyone who knows what to look for. Future scientists studying this layer might conclude that massive volcanic eruptions occurred around this time, or that a series of asteroid impacts released stored carbon from the Earth's crust. They would need very sophisticated understanding of isotope geochemistry to recognize it as the signature of fossil fuel combustion. Most might never make the connection. The spike would be filed away as another unexplained anomaly in the geological record, interesting but not critical to understanding the planet's deep history. Another mystery to be solved when better instruments became available. If better instruments ever became available. 10 million years later, continental drift has carried the continents to new positions. Africa has begun to split along the Great Rift Valley. Australia has drifted north toward Asia. The Atlantic Ocean has widened, while the Pacific has narrowed. The very geography of our world is unrecognizable. In sedimentary rocks around the globe, that thin layer of carbon isotope anomalies persists, now buried under miles of accumulated sediment, but still detectable to sufficiently advanced instruments. It forms a chronological marker, a brief moment in Earth's history when atmospheric chemistry changed with unprecedented speed. But what caused the change? Volcanic activity? Cosmic impacts? Some unknown natural process? The truth is written in chemistry so subtle that it might never be decoded. Even if future civilizations develop the technology to read isotope ratios with perfect precision, they might lack the wisdom to interpret what those ratios mean.
We would be invisible to them. Our cities, our art, our literature, our music, our dreams of touching the stars, all of it reduced to a barely detectable shift in the carbon chemistry of ancient rocks.
A civilization that split atoms and decoded DNA and sent machines to Mars might be remembered by the universe as nothing more than a slight anomaly in the geological record, if it was remembered at all. Dr. Adam Frank sits in his office at the University of Rochester, staring at computer models that simulate the long-term detectability of industrial civilizations. The results are sobering. Most of what we think of as permanent would be gone within 100,000 years, he explains, pointing to graphs that show the decay curves of different materials. Metals rust, concrete crumbles, glass weathers to sand. Even our most durable monuments would be reduced to rubble. But the models reveal something more disturbing. The same processes that would erase our civilization have probably erased others as well. The Paleocene-Eocene thermal maximum, that mysterious warming event 56 million years ago, left a chemical signature nearly identical to what our own industrial civilization is creating today. Massive carbon emissions over a geologically brief period, ocean acidification, global temperature spikes, ecosystem collapse. The conventional explanation, volcanic activity, requires a series of precisely timed eruptions that seem almost too convenient to be natural. What if it wasn't natural at all? What if it was the chemical obituary of an earlier technological species? The scary thing, Frent continues, is that we might be looking at our own future. If we can't solve climate change, if our civilization collapses from environmental degradation, we'd leave exactly the same isotopic signature that we see in the PETM. Future scientists might conclude that the 21st century was a period of unusual volcanic activity. They would never guess that intelligence had briefly awakened on Earth, looked up at the stars, and dreamed of touching infinity before destroying itself with its own success. The thought experiment forces us to confront uncomfortable questions about the nature of intelligence, progress, and cosmic purpose. If advanced civilizations inevitably leave detectable traces, why haven't we found definitive evidence of our predecessors? Either we really are the first, a possibility that seems statistically unlikely given the age of Earth and the universe, or the traces are so subtle that we lack the wisdom to recognize them. The second possibility is more troubling, because it suggests that intelligence might be common in the cosmos, but inherently self-destructive. Civilizations might regularly evolve to the point where they can manipulate their planetary environment on a geological scale, but they consistently fail to develop the wisdom necessary to use that power sustainably. They burn bright and die young, leaving only chemical fingerprints for the next experiment in consciousness to puzzle over and misinterpret. We scan the stars searching for alien intelligence, never imagining that we might be surrounded by the graves of previous civilizations. Not just on other planets, but on this one. Not just in distant galaxies, but in the rocks beneath our feet. Earth might be a cosmic cemetery where intelligence comes to die. But there's another possibility, more hopeful but equally profound. What if some civilizations do learn to survive? What if they develop technologies and social systems that allow them to maintain advanced societies without destroying their planetary life support systems? Such civilizations might still be here, not as ruins or chemical traces, but as ongoing experiments in sustainable intelligence. They might have learned to live so lightly on the planet that they leave no detectable footprint.
They might have developed closed-loop technologies that mimic natural ecosystems. No waste, no pollution, no irreversible damage to the biosphere.
They might be watching us right now, waiting to see if we'll join the galactic community of sustainable civilizations, or add our chemical signature to the geological graveyard of failed experiments. The UFO phenomena that has puzzled humanity for decades might not be visitors from other star systems. It might be surveillance by our own predecessors, intelligences that achieved technological transcendence millions of years ago and now monitor each new species that approaches the same critical threshold. They can't intervene directly. Each civilization must solve the puzzle of sustainable technology on its own, just as they did. But they can observe. They can study. They can hope that this time will be different. That we will be different. Indigenous wisdom traditions around the world speak of hidden peoples who withdrew from the surface world when it became too polluted and dangerous. The Hopi describe the ant people who helped humanity survive previous world destructions by taking them underground. Hindu texts mention the Nagas, serpent beings who live in vast subterranean cities and possess advanced knowledge of science and technology. These stories are usually dismissed as mythology, but what if they're racial memories of actual events? What if previous civilizations, facing environmental collapse, developed technologies that allowed them to survive in hidden locations, deep underground, beneath the oceans, or in dimensional spaces we don't yet understand? They might still be there, watching, waiting, hoping we won't repeat the mistakes that nearly destroyed them. The anomalous objects that military pilots report, craft that move with impossible acceleration and defy known laws of physics, might not be alien at all. They might be the technology of terrestrial civilizations that learned to transcend the limitations of chemical propulsion and electromagnetic energy. Technology that uses principles we haven't discovered yet, but that they developed out of necessity when their survival depended on finding alternatives to the destructive systems that nearly killed them. The mathematics of cosmic time make one thing clear. We are not special. Earth has existed for 4.5 billion years. Complex multicellular life has been experimenting with different forms for over 500 million years. Intelligence has probably emerged many times in many forms across deep time. The idea that we represent the first and only technological civilization on this planet requires a level of cosmic arrogance that borders on the absurd. It's like claiming that you're the first person to walk down a particular street, even though the street has existed for thousands of years and millions of people live in the neighborhood. Statistically, we are almost certainly not the first. We are the latest, the most recent experiment in technological intelligence that Earth has produced. But we might be the first to recognize this truth. The first to study deep time systematically, the first to develop instruments sensitive enough to detect the chemical signatures of previous civilizations. This knowledge gives us a unique opportunity and a terrible responsibility. We can learn from the failures of our predecessors. We can study the patterns that led to their collapse and choose a different path. We can become the first technological civilization on Earth to survive our own success. Or we can ignore the warnings written in stone and chemistry, convince ourselves that we're special and unique and destined for greatness, and add our own isotopic signature to the geological graveyard, the choice is ours. The window is closing. The chemistry of our atmosphere and oceans is already changing in ways that echo the great collapses of the past.
We know what happens next because it's happened before. The question is whether we have the wisdom to choose differently. Tonight, as you lie in bed in the darkness, remember this. The atoms in your body have been cycling through this planet for billions of years. The carbon in your bones might once have been part of a T-Rex that hunted through primeval forests. The iron in your blood might have been forged in the core of a star that exploded before our solar system was born. You are literally made of cosmic dust and stellar fire assembled temporarily into a pattern capable of consciousness, wonder, and choice. Your ancestors, biological and perhaps technological, have walked this same path. They have faced the same challenges. They have made the same discoveries and the same mistakes. Some found ways to survive and transcend. Others collapsed into chemical memories preserved in sedimentary rock. All of their experiences, all of their knowledge, all of their warnings and wisdom flow through you. You are not separate from deep time. You are deep time made conscious of itself. The future of intelligence on Earth depends not on whether we can build faster computers or more powerful weapons, but on whether we can learn the lessons that have been taught so many times before. The lesson that intelligence without wisdom is a cosmic dead end. The lesson that technological power without environmental responsibility is a path to extinction. The lesson that we are not above nature, but part of it, and our fate is inseparable from the fate of the living planet that gave us birth. We are the latest chapter in a story that has been told many times across millions of years. We can choose to be another tragic ending, another mysterious isotope spike for future archaeologists to puzzle over. Or we can write a different conclusion. We can become the first civilization on Earth to learn from the graves of our predecessors and choose the narrow path between technological transcendence and environmental collapse. We can become the first to survive. The stars that shine down on you tonight have witnessed the rise and fall of countless civilizations across cosmic time. They have seen worlds bloom with intelligence and die in darkness. They have watched the universe experiment with consciousness across billions of years and billions of worlds. Most of those experiments have failed. Intelligence has emerged, burned bright, and faded back into the cosmic dark without leaving permanent traces. But some have succeeded. Some have found ways to harmonize technology with wisdom, power with responsibility, individual ambition with collective survival. They have become gardeners of life rather than consumers of it. They have learned to tend the delicate flame of consciousness rather than burn it out in pursuit of temporary glory. They are still out there, somewhere in the vast darkness between stars, still learning, still growing, still hoping that each new civilization that approaches the threshold will have the courage and wisdom to join them. The question that will define our species is simple. Will we become ancestors to the stars, or just another layer of carbon in the rocks? Will future beings remember us as gods who transcended their limitations and seeded the galaxy with life and consciousness?
Or will they never know we existed at all? The answer lies not in the distant future, but in the choices we make today, in this moment, in this breath, in this chance to learn from deep time and choose a path that leads not to extinction, but to transcendence.
The universe is watching. The ancestors are watching. The stars are watching. You've seen how fragile empires are, how easily greatness can disappear. Don't just be a silent witness. Show that you were here. Like this video, subscribe to this channel, and turn on notifications. Otherwise, this story slips into the same silence as the past we uncover.